All right, good morning, everybody. So to begin the lecture, I just want to clear up the confusion I had in the conditional expression or the conditional statements notebook. So when you use minus v, you always give the variable name of the variable that you want to test if it has been assigned a value yet. So you don't put the $ in front of our name. Now the confusion that occurred in the last lecture was if you put in the name of a string, does that test if the string is not empty? And the answer is no. So in the string expressions, you have to put in an actual string. Right? So if you have a variable that's a string, you need to use the $, to get the value of this string. So this was the cell that caused some issues here. I think the notebook was originally written like that. So if you write that, s is the name of a variable, but it's also a string, right? It's the string s. And so it turns out that bash evaluates this as, is s empty? And the answer is no, right? The string s, sorry, the character s is a string, it's not empty, so this print's not empty. If you want to test if the string stored in s is empty, you must use the $ in front to get its value, right? And so, this is the correct form of this test here, right? If you want to test if a string is empty or not empty, get the value of the string and use that as the condition. Okay, so for today we're going to look at bash arithmetic. There isn't much to say about arithmetic in bash, it's pretty straightforward. And then we're going to look at regular expressions. So let's handle arithmetic first. So arithmetic in bash works the same as arithmetic in more or less Python, with the exception with a couple of exceptions. Everything in bash is an integer, so there is no floating point arithmetic. You get exponentiation like you do in Python, so there is a star operator, which is a little bit unusual, right? C and Java don't have this operator. And the other thing that's different than Python is that there is a range on the value of integer values in bash. The range depends on what version of bash you're using, and what operating system you're using, and so on and so on and so forth. But there is a finite range, just like in Java and C, right? So you will get overflow. It's possible to get overflow in bash with its arithmetic. The double round brackets are used to indicate an arithmetic expression. Double round bracket, x equals 1 plus 2, simply evaluates the expression inside the double round brackets as an arithmetic expression. Notice that, so here we're declaring a variable x, right? We're computing the sum 1 plus 2, and we're assigning the sum back to x. Notice inside the round bracket, spaces don't matter, right? Outside round bracket, the double round bracket, spaces matter. Inside the double round bracket, bash understands you're writing an arithmetic expression. And so it doesn't care if you have spaces or not, right? It's not trying to parse the stuff inside as some sort of bash expression, right? It simply assumes it's arithmetic and away it goes. So this actually works. There's no error. You get 3, right? If you take away the spaces, sorry. If you take away the spaces, same thing, doesn't matter. Similarly, you don't need the space after the second opening round bracket, unlike with the square brackets where you need the space, right? Similarly, inside double round brackets, bash assumes everything is arithmetic, so you don't have to use the $ to get the value of a variable. Right? If you write something that's not a digit inside double round brackets, bash just assumes you're trying to get the value of a variable. So z equals x times y. You don't need to write $x. You don't need to write $y here. Right? And that works just fine. You can write $x and $y if you want to, so there's no issue using the $ operator to get the value of. Right? But they're not required inside double round brackets. Okay, so what happens if you use a variable that hasn't been declared yet, or a variable that's not an integer, or whose value is not convertible to an integer inside double round brackets? In all of those cases, bash takes the value of that thing to be 0. So here we've got x and y. X is ABC, right? Y is 5. Compute the sum, you get 5. Right? It treats the value of x as though it were the value 0. Right? You don't get an error, right? This is one of the this is one of the things you have to get used to in programming in bash. Often you don't get an error when you would expect an error to occur. So you can in fact add ABC to 5, the answer is 5. You can add the empty string to 5, the answer is again 5. You can get rid of x completely and compute x divided by y, and you get 0, it's fine, right? So unset variables, variables that are not integer values, they all get set to 0, or their values are taken to be 0. The double round brackets are actually a command in bash. And so when you write double round brackets, some mathematical expression, that produces an exit status. The exit status is a bit funny, so it's a bit weird to wrap your head around. If the result inside the expression is 0, the exit status is considered to be 1. So in other words, it's considered to be false, right? If the expression inside the round brackets is non-zero, then the exit status is set to 0. In other words, it's taken to be true in bash. So a bit weird, right? So the exit status of 0 plus 0 is 1, and the exit status of 0 plus 5 is 0, right? So if you were to use this as a condition in an if statement, it would not run, right? Its exit status is 1, that's considered to be false, right? And so that won't run. Here it is non-zero, so that's considered to be true, and away it goes. Okay, so you can use it as a condition. If you're doing numeric comparisons, I recommend you use the double round brackets as your, to indicate that you're evaluating a condition instead of the double square brackets, right? It's easier to read the expression inside the double round brackets, right? Mostly because it looks exactly like it looks like in Java or Python, right? So is the number of arguments passed to the script not equal to 1? In this case, it turns out that's an error. So we output an error message, right? We looked at these in the last class, so I'm just going to go over them quickly. Is the number of input arguments less than 3? If it is, for this script, it's an error condition. So we print out an error message and exit. There's divide by 2, right? So if there's at least one input, if there's at least one command line argument, right, get the value of the first command line argument. We're going to assume it's a number, right? If it's not a number, then when we evaluate value divided by 2, take the remainder, value will just be 0. And so you're going to get 0, which is even. Right? So this tests if value is odd. If it's odd, we exit with 1, and if it's not, we exit with 0 down here. Right? And so is even simply tests whether or not that value is even. Right? Setting the exit status to 0 if it is, and setting it to 1 if it's not. So is 2 even? The answer is no. Is 3 even? The answer, sorry, is 2 even? The answer is yes. Is 3 even? The answer is no. Okay, and last example, because integer arithmetic really isn't that interesting. This is generating a random number in bash. If you need to do robust random number generation, don't do it this way. If you just need a random number for some reason, then it's fine to do it this way. Right? If you're trying to do cryptography or something important, don't do it this way. So bash's random number generator is a little funny. So first of all, bash defines a variable called random, right? All caps random. Every time you access the value of random, it changes. Thus, it's random. So bash's random number generator is basically accessed via a variable called random. Right? It's a bit funny. So its range is quite limited. So it's between 0 and 32,000. That's the only choice you have. Right? If you need some other random, if you need a better random number generator, you have to find a better random number generator. Right? Don't use big R random for this case. But if you want just simple random numbers, you can easily write a script that lets you generate a random number between 0 and 32,000. Right? That's easy. You just look at the value of random. Now, you might want a value between 0 and some other number. Well, that's pretty easy too, as long as the other number is less than that. Right? And similarly, you might want a random number between some smallest value and some largest value, as long as the range is less than 32,767. That's also relatively straightforward. right? And the script shows you exactly how to do that. So our script called rand tests the number of input arguments. So if there's more than 2, then this script complains you've used the wrong number of arguments. If there are no input arguments, so someone writes rand.sh, then you simply get back a random number between 0 and 32,767. Right? How do I get that value? Well, you just look at random. Right? Every time you look at random, it's a different value. If there's one number, the script gives you back a random number between 0 and the input argument. Right? Assuming the input argument is less than 32,767. Right? How do you get a value between 0 and some number minus 1? Just compute the remainder after division, dividing by the value. So if you wanted a random number between 0 and 5, you would pass in the number 6. Right? And away you go. There's another bug here, sorry. Between m and... I guess what I meant was this. Yep. There we go. Okay, if you want a random number between m and n minus 1, you have to do a little bit of work. The trick here is you compute the range between these two values, right? So you take the one value, you take your value n, and you subtract m, right? That gives you the range between m and n, or the width of the range between m and n, right? You now compute a number between 0 and the width of the range minus 1, and then you add back m, right? So you add back the smallest value, and that gives you a random number between m and n minus 1, right? So compute the width of the range, right? Take your random number, divide it by the width of the range, compute the remainder, add back the smallest value, and that produces a random number between the first input argument and the second input argument minus 1. Right, and so here's some examples of running the script. So random number between 0 and 32,000. Right, run it again, and again, you get back random numbers, which is good. Right, random numbers between 0 and 9. Right, 0, let's see if we can get a 9. Yeah, and if you run it a bunch of times, you will never get 10. Right, and 30 and 40. So run it a bunch of times, you'll eventually get 30. Eventually, we'll get a 39 at some point. Oh, there we go. There was a 39, right? But you'll never get 40, right? And so there's that's basically bash arithmetic in 10 minutes. Right? There really isn't much to it. It's also not super common to use. The only time you might find yourself, that's not the only time. Probably the most common the most common occurrence of using arithmetic is when you're computing something using indexes of some kind. Right? Either you're trying to get something out of a string, or you're trying to get something out of an array. We'll talk about arrays in a future lecture. Okay, any questions about arithmetic in bash? It's pretty straightforward, right? If you want the value of the arithmetic expression, right, you can always use $ in front of it. Right, so remember there is an arithmetic expansion, right? And so that looks exactly like this. Right, so double round brackets x, that just gives you the value of x, right? I can extract the value of the expression with the $sign. And so I can print the value of y here. Right, so 3, you can do an arithmetic expression here if you wanted to, right? This should be 4, and so on and so on and so forth. Right, so double round bracket to evaluate an arithmetic expression. If you need the value of the expression, $sign, double round bracket, and away you go. Okay, the next notebook is regular expressions. So a regular expression is a way to define a pattern for strings. We've already seen some patterns in bash, right? So you know about the star, the question mark, and the square brackets, right? And so those let you generate relatively simple patterns for strings. Regular expressions are more powerful expressions to define patterns of strings. They are quite powerful. They're also hard to use. So here's a quote from Jamie Zawinski. So some people, when confronted with a problem, think, I know, I'll use regular expressions. Now you have two problems. And so this comes from regex.info, which is a well-known website that talks about regular expressions. They are very commonly used, so a lot of web services use them. So they're anything that does input validation. So is this a phone number? Is it an email address, right? Probably uses a regular expression to check whether or not this thing that the user has typed in actually is a phone number, or a postal code, or possibly an email address, and things like that. Right? So they are used quite a bit. Now, what you have to remember is that Bash has its own pattern language, right? Star, question mark, square brackets. Regular expressions are different, right? So they define their a regular expression has its own language. Well, a regular expression is a language actually, and so they have their own way of specifying patterns, right? The confusing part is the symbols are the same. Regular expressions also use the star, the question mark, and the square brackets, right? But they mean something different when you're using a regular expression. The idea comes out of theoretical computer science and formal language theory. If or when you take Sys 223, you might get a little bit of the theory that where you might learn a little bit about where these regular expressions come from. Right, 223 tells you about automata and grammar-based techniques, right? So grammar is how do you specify a language, right? And so this is regular expressions came out of the out of theoretical computing science, right? And people who studied programming languages. Okay, so so this notebook doesn't pretend to cover everything you need to know about regular expressions. If you click on that link there and look at that website, it's a very big website. It's a fairly big website. And so it turns out there is a lot to know about using regular expressions in practice. So you're only going to get a little introduction to it. Okay, so one of the conditional operators that you are allowed to use with strings is equal tilde. Right? And so equals tilde performs what's called a regular expression match. Right? The regular expression always goes on the right-hand side. Right? So if you have a pattern that you want to match, that pattern always goes on the right-hand side. The string that you want to test if it matches that pattern always goes on the left-hand side of the operator. Right? So here we can test, does that string match that regular expression? And if it does, we'll print out string matches the regular expression. Right? If it doesn't, we'll print out it doesn't match the regular expression. Right? Okay, now you have to be very careful inside double square brackets. Right? So remember, inside double square brackets, you normally don't have to quote any of your parameter expansions, right? So you normally don't have to quote that. You normally don't have to quote that, right? If you quote the regular expression, right, that forces the entire pattern to be matched as a string instead of as a regular expression. So if you quote the regular expression here, you don't get regular expression pattern matching, you just get string matching. So if you mean to be doing, if you're writing that, don't quote that. It's almost certainly wrong. Right? If you quote part of this thing here, then whatever part you quoted there gets matched as a regular string. It doesn't get matched as part of a regular expression. Okay, so working with regular expressions is hard. And so it's often useful to have something that can tell you whether or not your regular expression is doing, to test your regular expression. So it's often useful to write a little script like test regex that tests whether or not one string matches a regular expression. Right? And so the number of input arguments for our script is 2, right? The string to match, the string to test, and the regular expression to test against. Right? So string, regular expression. Right? The first argument is the string that is the thing on the left-hand side. Right? The second thing is the regular expression on the right-hand side. And we're simply going to test this here. So when you're debugging your regular expressions, it's often handy to have either this script or if you go online, there's lots of regular expression testers that you can find. Right? So we're going to be using the script a little bit in this lecture. Okay, so the type of regular expressions that we're talking about are these things here, right? Formally, they're called the POSIX extended regular expressions, right? It turns out there's many different types of regular expression languages. Many of the bash commands will let you specify exactly what kind of regular expression you're writing. The commands that we're using by default, that's not true. So the equals tilde operator by default uses the extended regular expression syntax. So that's the one we're going to be using. Some of the commands that we're going to be using for regular expressions don't use the extended regular expression syntax. They use something else. You can tell the command to use the extended regular expression syntax. Okay, so what if your regular expression consists of just some regular characters, right? So nothing, no unusual symbols, so it's just a plain old string, right? So if your regular expression consists of just a plain old string, then what you're asking is, does your string contain at least one of these things here, right? It's not testing, does it start with an A? It's not testing, does it end with an A? It's not testing, is it A? Right? It's testing, does your string contain an A? Right? So does hello contain an A? The answer is no, right? Does walrus contain an A? The answer is yes, right? The A is right there, right? Does A contain an A? Absolutely, right? Does a bunch of, oops, sorry, control, oh. Right? Does the string made up of a bunch of A's contain an A? The answer is yes, right? So, plain old string here, you're testing, does this string contain that string, right? And so, let me test, okay. Let me change this one here. Well, ABBA. So, does our string contain the sequence AB? The answer is yes, it does contain the sequence AB, right? Does it contain the sequence BB? The answer is yes, right? Does it contain BBAA? The answer is no, right? And so there you go, right? So if you want to test, does a string contain a substring? Don't do anything fancy with the substring, right? The string matches the regular expression and, if the string, yes, okay, that's exactly the example I just showed you here, right? So does the word hangry contain and? The answer is no, right? Does Sandman contain and? The answer is yes, right? And away you go. Okay, so simple strings, easy, right? It's basically, does the string contain a substring? Okay, so now you've got a bunch of ways. You need to know, how do you define how do you actually define your pattern now, or more complicated patterns? And so for that, you need to know about what are called the meta characters. So the meta characters are symbols that have special meaning to a regular expression, right? Some of these have special meaning to bash, right? Some of them don't. So you have to be careful when you're using these, right? So your meta characters are the caret, the $sign, right? So notice the $sign shows up as part of your regular expression language, right? It's not getting the value of a variable in this case, right? It's being used for something else, right? You've got the dot, square brackets appear here, right? Square brackets with a caret appears here. You get the double round bracket, so parentheses. There's star and question mark, right? You get the plus sign, you get the braces, and you get the vertical bar, right? Different versions of the regular expression syntaxes may use different sets of meta characters. Right? Okay, so there is a description for all of these meta characters. It's probably easier, though, to look at some examples to see exactly what it is that they do. Right, so let's do that instead. So here's a little table that describes, that gives some regular expressions, and it tells you the strings that they match. Right? So we know what a plain old string does as a regular expression, right? It tests whether or not, so any string that contains the substring hello will match the regular expression hello, right? Now you might want to match hello exactly, right? So in other words, you need to know the string is exactly the string hello, right? In that case, you should probably just use equals or equals equals, If you want to use a regular expression, you have to say, I want to match the regular expression that starts with an H, is followed by an E, is followed by an L, is followed by an L, and ends with an O, right? So that's how you have to think about these regular expressions, right? They're generating sequences or patterns of characters. So how do you say starts with an H? You say caret H, right? How do you say ends with an O? You say O $, right? So the $sign here is being used to mark the end of the string. What exactly is it? An anchor. So it matches the end of a line when used as the last character of an expression, right? Caret H matches the start of, caret matches the start of a line. So caret H says your line or string must start with H, right? And so that will only match the string hello. Right. So again, using the anchors, and now we've got the dot. Right? So dot matches any single character. Any single character, including the empty character. I don't know if it matches the empty character or not. I think it does. We should check that in just a second. So this, apparently it does. I don't think it does. I think it has to match a single non-empty character. So your string starts with any character and must end with an O. In between, it must be ELL. So this will match one LO, A, LO, Jello, hello, right? And anything else. Any 5-character string that ends with an O. You can use dot dot anywhere. So you can use these meta characters or use the dot meta character anywhere in your regular expression, right? Anywhere that you use it, it means match any character here. So anchor H starts with an H, right? O anchor ends with an O, right? So starts with an H, is followed by 2 characters, ends in LO, right? So H1, 1 LO, HA, YLO, H at MLO, and many, many more, right? Any 5-character string starts with H, ends with LO. Right? Square brackets means the same or something similar to what Bash thinks the square brackets means, right? It defines a character class. So that will the character class matches any character inside the character, any single character inside the character class. Right? So starts with an S, ends with a T. The middle character is one of A, E, or I. So that matches sat, set, or sit. You are allowed to use ranges of characters. So A through Z, or A hyphen Z means the letters, the lowercase letters A through Z. So again, starts with an S, right? Ends with a T. And so that matches all 3 letter strings made up of lowercase English letters that start with an S and with T. The minus sign as the first character inside the character class means also match the minus sign, right? So here you've got A through Z, right? Notice the hyphen is special. It's defining a range. If you want the hyphen to be part of the range, right, it either shows up at the start. I think it can show up at the end. No, I don't think it can show up at the end. It has to show up at the start of the character class, right? So this also matches S hyphen T, and then everything else that this matches as well. Right, so again, notice the special treatment of the hyphen. Because it's used to define a range, it requires special treatment inside the character class as well. Right? You can define a range of digits, so 0 through 9. That matches, this will match file 0, file 1, up to file 9. Right? If you want to match the period specifically, right, you can't just write the period, because the period means match any single character. So if you need to match explicitly the period, you have to put it inside a character class. Right? So A square bracket dot square bracket C only matches A dot C. Right? This is also true of any of the other meta characters. Right? So if you need to match any one of these explicitly, they go and you have to put them inside square brackets. Okay, so why is this? I wonder why this line is here. I guess you can play. I guess if you wanted to, you could play around with these regular expressions and try them out here. I think that's the intent, right? So, oh, let's change this one. So let's change our regular expression so that it starts, right? So starts with an H, ends with an O. So does say hello match that? The answer is no, it's not matched, right? Take away the anchor. Oh, take away the first anchor. So this means, does your string end with hello, right? It doesn't care what's in front of the hello, but does it end with the hello? So this one says it is matched, right? Take away the end anchor. That means, does your string contain hello, right? Put in a dot somewhere, right? Does your string contain an H followed by anything followed by LLO, right? And it does, right? I guess this is a good time to test this. So if I remove that, does it match the blank? Does it match the empty character? It does not. So this has to be an actual character. And you can try, I guess, the other ones as well. Right? And so if you want to play around with it, and I recommend you do play around with these, you can try it out in the notebook here. Okay, and so those are some simple examples of regular expressions. Right? Okay, so inside a regular expression, right, every single character that's not a meta character, right, is called an atom. Right? So in my regular expression here, right, H is an atom, the L is an atom, the second L is an atom, and the O is an atom. Right? If you have round brackets, that groups stuff inside of a regular expression. So that's called a sub-expression. Sub-expressions are also atoms. Right? Finally, bracket expressions are also atoms. Where are the bracket expressions? These. So when you define a character class, those are also considered to be atoms. Right. Okay, so a regular expression lets you specify how many times should an atom be matched. Right. So you get star, question mark, plus, and the brace expression here. So that lets you modify how many times is the preceding atom matched, right? This should say not all meta characters. Some of the meta characters are considered to be atoms. So in particular, the dot is considered to be an atom, right? Okay, so what the heck does star mean, right? So remember star, that inside for a regular bash file name expansion or in a bash glob, right? Star matches anything, right? Any sequence of characters. Inside of a regular expression, star means match the preceding atom 0 or more times, right? So the star modifies the atom in front of it, right? So that thing there, right, starts with any single character, right? Star. So the star modifies that thing there, right? And so remember, star dot star means match any single so the star means 0 or more occurrences of any single character, right? And so that matches all strings, including the empty string, right? Starts with that, starts with something, ends with something. The stuff in between is anything, right? So dot star, right? Any single character 0 or more times. So caret dot star question mark dollar sign, right? Oh wait, these are backwards, sorry. Caret dot star dollar, there we go. Okay, so does the empty string match that regular expression? The answer is yes, right? The string, empty string, is matched by that regular expression, right? This thing will match anything, so it doesn't matter what you type in here, right? It will always match, right? Any character 0 or more times. The plus sign means 1 or more, right? So this says match any non-empty string, right? So there has to be one of the preceding character, right? And so this matches any non-empty string. Let's change that to a plus, right? Try the empty string, right? Is not, so the empty string is not matched by this, right? Is the string of length 1 matched by this? The answer is yes. Right? Does it matter what you change this character to? The answer is no. Right? I'm inside double quotes here, so this takes away the special meaning of the star. Right? Okay, question mark means 0 or 1. Right? So this means match any string of length 0 or 1. Right? Again, you need the anchor here and the anchor here to force it to match a string of 0 or 1. If it's just dot question mark, that will match anything, right? Yes, that'll match anything. Right. So dot question mark, right? So that'll match the empty string, right? It'll match a string of length 1, but it will not match a string of length 2 in this case. Oh wait, it did match it. Dollar, oh, I forgot the, sorry, trailing there. Right, so that's not matched. Right, if you drop off the dollar sign, right, the closing dollar sign, remember this says starting with 0 or 1 occurrences of any character. Right, so that'll match pretty much any string, I think. And so that is not matched. Good. Okay. Okay, so this goes back to the previous examples. So here we've got a character class, right? Square brackets 0-9. So that matches any string containing a digit, right? There's no anchors, right? The character class is the digits 0 through 9. So this matches any string that contains a digit, which might be useful, right? What happens if you put a plus in after the closing square bracket, right? Well, it means the same thing, right? So remember what plus means. So just go back up here, right? Plus, match the preceding element or atom 1 or more times, right? So if you put the plus after this, you're looking for a string that contains at least 1 digit, right? In other words, it means the same thing as this, right? Now what happens if you put the anchors in? Right, so if you put the anchors in, this matches any unsigned integer, right? So this says match a sequence of digits of 1 or more digits, right? The anchor here and the anchor here forces that string to only contain digits, right? So remember, in bash, everything's a string, so you can write down any number of digits that you want. If you try to convert it to an int, it may overflow, right? So the string is fine, right? The string of 500 ones is fine. If you convert it to an int, or if you try to use it in an integer expression, an integer arithmetic expression, it will overflow. What happens if you want a negative number? Well, you just slap a negative sign in front, right? So exact same as the previous one. Put a negative sign in front, and now you've got any negative integer. So what happens if you want a signed integer value? So in other words, you want plus or minus, right? Where the plus or minus is optional, right? So plus or minus, I can put that inside of square brackets, right? So that will match the plus or the minus sign, right? Question mark means 0 or 1, right? So there can be 0 or 1 plus or minus signs, followed by any number of digits, right? So that gives you any signed or unsigned integer, right? Finally, you can also, instead of using the ranges, you're allowed to use the POSIX character classes as well, right? So square bracket, colon, digit, colon, square bracket is the POSIX character class for digits, right? So if you wanted to, you could write it that way. That's shorter. I think this is the more portable way to do it. So if you are worried about if you're worried about writing your scripts not just for Bash, but for other scripting languages, the second form is more portable. Okay, any questions about the quantifiers yet? These are called quantifiers because they affect the number or specify the number of times that the preceding atom must match. Okay. The braces also let you define quantifiers. So here, and remember, it affects the atom immediately in front of it. So that 1 says the atom in front of it must occur exactly once. The atom in front of the 1 is the A, right? It's not the XA, right? So it's the A here. So this says starts with an X, ends with exactly one A, right? So that matches XA and only XA, right? So we can try that out down here. So starts with an X, matches, followed by exactly one A, right? So does X match that regular expression? The answer is no, right? Does XA match that regular expression? The answer is yes. XAA, the answer is no, right? So this only matches XA. If you put the comma in and nothing after the comma, that means whatever number this is, so one or more, right? So starts with an X, followed by at least one A, right? Ending with an A, right? So put the comma in here, right? And so now that matches, right? If you end with a different letter, it will not match, right? If you wanted to match XAAB, oops, sorry, I lie. I keep on forgetting the last anchor. There we go. So, right, XAAB doesn't match because the anchor here says that it must end with an A, right? Take the anchor away, it does match, right? Because now you're testing, does this string contain or start with an X followed by one or more A's, right? But it doesn't say anything about how it ends. Okay, if you put the number after the comma, that forces it to be 1, 2, or 3 in this case, right? So has at least that many and at most that many, right? So at least one A and at no more than 3 A's. So that matches XA, XAA, and XAAA, right? And finally, you get the round brackets. So the round brackets define a sub-expression, right? So here our sub-expression is the string ABC, and it's inside round brackets, right? The round brackets causes the ABC to be treated as an atom. So the plus sign now affects the atom ABC, right? Plus means one or more, right? So starts with, right? Starts with ABC, right? One or more times, and then ends, right? So it'll match ABC, 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 and so on and so on and so on, right? So if we plug that in, and the plus sign here. Okay, so the empty string will not match that because it does not contain ABC, the empty string, right? ABC will match that, right? If you end with something that's not a C, it definitely will not match, right? And in fact, if you end with anything that's not ABC, it also will not match, right? There we go. All right. Finally, there's the vertical bar operator. So you can join two regular expressions using the vertical bar, right? The vertical bar sort of means or. So the resulting regular expression matches any string that matches either of the joined expressions. This one's a bit tricky because you have to remember you have to figure out what is the regular expression before the vertical bar and what is the vertical expression after the bar, right? Okay, so here is A vertical bar B, right? So your regular expression before the vertical bar is the A. So remember that matches any string containing an A, right? The regular expression after the vertical bar is the B. So that matches any regular expression, any string containing a B, right? So this overall regular expression says match any string containing an A or any string containing a B, right? So does Java contain an A or a B? The answer is yes, right? Does banana contain an A or a B? The answer is yes, right? Dog, right? Does dog contain an A or B? The answer is no, so it does not match, right? Okay, again, you have to be careful with the before and after parts, right? So the bar is probably one of the most confusing ones to use. So what's the regular expression before the bar? Well, it's the caret B. So that means starts with a B, right? So any string starting with a B will satisfy the regular expression in front of the vertical bar. This says must end with cat, right? So any string ending with cat also matches this regular expression, right? So this will match B vertical bar cat dollar, right? So any string starting with a B, so bat will match that, right? Or ending in cat, so cat will match that, right? Black cat satisfies both, right? It starts with a B and it ends with cat, right? White cat ends with cat, so that also matches, right? And away you go. Okay, again, you can combine all of this stuff together, so it becomes a little bit more complicated. Now here, right, this is the way that you might think how you can match bat or cat. And it's true, it does match bat or cat, right? So this also matches bat, right? But it also matches a bunch of stuff that's not bat or cat, and that's the tricky part with regular expressions, right? It's often easy to write a regular expression that matches the thing you want, but it's also easy to write a regular expression that matches the thing you want, plus a bunch of other stuff that you don't want. So if you really wanted to match bat or cat, and you really wanted to use a vertical bar, the way you have to do it is this, right? So regular expression in front of the vertical bar, right? Sorry, this one's not going to exact any strings. Sorry, this isn't quite right yet, right? So we're getting there. So starts with a B, right? After it says it must start with a C, right? And then is followed by AT, right? So this matches any string starting with B, right? So anything starting with that, any string matching that regular expression, so anything starting with a B, or matching that. So if you stare at that regular expression long enough, you'll realize that's just the expression cat, right? So that will match anything starting with a B, carrot, like that. So that matches bat. It matches cat, right? Unfortunately, it also matches stuff like black, which is probably not quite what we're after yet. Okay, so you want to force it to match only bat or cat. So how do you do this, right? Okay, so you need to, in this case, you need to use a sub-expression like that, right? So if I put all of this in a sub-expression, right, the thing in front of the vertical bar is the starts with a B. The thing after the vertical bar starts with a C. Everything after the sub-expression means ends with AT, right? So that's the one that matches bat or cat exactly, right? The easier way to do this is square brackets BCAT, right? Caret in front, $sign at the end. All right, I will leave you with this. So I'll leave you to figure out what these regular expressions match. And we will pick up this notebook in the next lecture. Right? So that's all we have for today.